A lot of my research focuses on making the unprintable printable. My name is Bradley Duncan. I'm a researcher at MIT Lincoln Laboratory. So what I do is I solve problems, usually ones that have a specific Department of Defense focus, in trying to use synthetic organic chemistry and material science to create ways of manufacturing things that you can't make currently. This project is a advanced packaging and additive manufacturing technology that we've been developing for the past few years here at Lincoln Laboratory, using a liquid system in order to deposit material that, upon curing, converts into a glass. This particular technique is called direct ink writing. I like to call it almost like, you're moving toothpaste across a build plate, and you're able to use, this deposited paste-like material to build up your structures in 3 dimensions. There are 2 really unique things about this particular project. The first is that with typical glass manufacturing or glass composites, all of that usually requires a very high heat treatment. We're talking 1,000 degrees Celsius. So if you traditionally, used plastic to create a glass object, it would just catch on fire. This process, alternatively, it deposits its material at room temperature, and then the curing process is around 200 degrees Celsius. Now you can imagine combining things like glass and plastic within an additively manufactured part. When you focus on creating very dense electronics, something called heterogeneous integration, and that's you're taking a bunch of different components and you're stacking them on top of each other. However, in order to stack all these components and kind of take all these different systems and combine them, you have to glue them together. And currently, that's the last step in the process. You can only do that step. And so you really can't build up truly in 3 dimensions for multiple layer stacks. And so, as we approach the end of Moore's law and, how far we can push things in this lateral dimension, the only place to grow is up. A layer by layer fashion into 3 dimensions, you're able to really control and create devices and geometries that traditional manufacturing can't achieve. And so what this does is this gives you the ability to kind of introduce a packaging material and introduce a way of building up in 3 dimensions that you can then go back into the clean room and leverage all of the technologies and all of the equipment that is very, very precise. That means that your cell phones can get smaller, they can become more powerful, the processing power of the computers can get quicker. So with this, the R&D 100 award, I think it really just spoke to all the hard work of the team. I know the amount of people contributing to this project is in, the 20s to 30s. So, it kind of showed, more broadly and more publicly that, this technology truly could have an impact from the lab out into the real world.